Okay, so now we have equation that force equal to gravitational constant into mass of the one object divided mass of the one object into mass of the another object divided by the distance between that the distance between that two objects square. So F equal to G into M1 M2 divided by R square. So let us say that we take this is the table. Let us say this is the table. This is the one object. This is the one cup, another cup. The mass of this is equal to, let us say that 0.25 kg. So this mass is also 0.25. Obviously, so as per the system, obviously there is a attraction between these two particles, two cups. Attraction force between the two cups. The thing is that the distance is 1 meter. Let us assume. Let us take 1 meter. 1 meter. You see that how much force is established from one cup to this cup on this cup on exerted force on this cup, and this cup exerted on this this cup. See that you take that this is the formula F equal to G into M1 M2 by R square. So here we know the G value, gravitational constant we found out already, is found out, and that is 6.67 into 10 to the power of minus 11. Units are newtons into meter square divided by kg square. Here M1 and both mass equal same 0.25 kg. So I have substituted here M1 0.25 kg, M2 0.25 kg. Distance between the two things, two cups 1 meter. That is let us say R, that is the 1 meter square, 1 into 1 meter square. So that if you simplify this numerical values, you can get 4.2 into 10 to the power of minus 12 newtons. You can imagine such a very small force, very small force, very small force that can rewrite in this form. You can imagine very insignificant small force is established between the two particles, while suppose because of that why even that force is there, why this object cannot get move while it tries to move, the frictional force is there. The frictional force is established in this direction, which means that even that force is there. 4.2 into 10 to the power of minus 12 Newton force is there between these two particles, but they are not, we cannot find any movement in this object, because this force is not much less than the frictional force which is established opposite direction of that object which tries to move in this direction, So what we can understand on this planet or in this universe, on this planet especially, there are several objects are there, but in each object between the two, the force is there, but is very negligible force, so that we doesn't feel that force. We doesn't feel that force, but that force, there is a force exerted by the earth on the object, any object, that is huge, that is significant, that we can go to next, that we are going to calculate that value. So from this gravitational force, from this what we can understand, the force is there between the two objects, attractive force is there, but is very insignificant. So that's why we didn't feel that force. We did that. So we calculate acceleration due to gravity. So we are discussing different topics to arrive that value. So next one is the gravitational force due to earth. Gravitational force due to earth. What is the gravitational force? So earth is we know that earth is a huge magnet. It has gravitational force. So that what is the gravitational force of the earth? Earth acting on the any object on this planet, we can calculate. So by using this equation, we know that F equal to G into M1 into M2 divided by R square. So in this equation, I would like to take the mass of the earth, let us say M1, that mass of the earth equal to already measured, that is the 6 into 10 to the power of 24 kgs. Please understand, 6 into 10 to the power 24 kgs. That is the mass of the earth. Mass of the object. Now we can take any object. I take one object, its mass equal to 35 kgs. I take 35 kgs. The radius of the earth. The radius of the earth equal to 6,400 kilometers. 6,400 kilometers, or if you would convert into the meters, so 6.4 into 10 to the power of 6 meters. So you coming to this equation, G value we know that 6.67 into 10 to the power of minus 11 Newton meter square by kg square. M1, this is the mass of the earth, 6 into 10 to the power of 24 kgs. This is the one object, a person or object, 35 kgs divided by radius 6.4 into 10 to the power of 6 meters whole square. If you simplify this one, you can get 342 newtons. This is the gravitational force of the earth. This is the gravitational force of the earth. Of course, this object, this is the object, we take object, the radius between, unless we move to the space or moon, the object between the any object between the this earth, that is nothing but radius. That is nothing but radius of that earth. That's why I have taken 6.4 into 10 to the power of 6 meters. So straight away radius. Any object on this planet, any object that earth, we can consider the radius. We can consider the radius. Of course, if the man is going upward direction, that radius may be increased. That radius is increasing, but unless otherwise that person, that object is getting to the space ship or moon, on this planet, on this earth, we consider the distance is r, that is we have to take 6.4 into 10 to the power of 6 meters. So the earth is gravitational force that is equal to 342 newtons. If this object is 35 kgs, of course, if you take even 100 kgs, we cannot find much change in this gravitational force. Of course, it is increased, we cannot find much change, much significant change in this force of the gravitational force of the earth, gravitational force of the earth. So that's why, because of this, any object, if you throw upward direction, it reaches maximum height when it velocity becomes 0, so that gravitational force is acting in this direction upward. That gravitational force of the earth is acting in downward direction. So therefore, that object is finally it falling down. While it is falling down, its velocity is keep on increasing, so that that acceleration is increasing. That acceleration for that earth acceleration due to gravity is 9.8. That we are going to find out next. So coming to this topic, before we are going to calculate acceleration due to gravity G value, this is the last one. The body is falling near the surface of the earth. Before this last one, these are the topics to understand to calculate the acceleration due to gravity. We studied in previous videos the universal law of gravitation, force required for circular motion, Newton's law of gravitation from planetary motion, gravitational forces in some common cases, common bodies, gravitation force due to earth, this calculated. So this is the last but one. The body is falling near the surface of the earth. Galileo, he made some observations. What observations he made? If there is a two objects, this mass equal to, let us say that 1 kg, volume equal to 0.25 meter cube. This another object, this mass equal to 0.5 kg, volume equal to 1 meter cube. Of course, they are allowing falling at the same height. What he observed, what he told, the both objects are reached more or less same time to the ground surface. Of course, we got some doubt. Obviously, what we considered the more mass object falling first. But Galileo observed that irrespective of their masses, depending on their sizes and mass, of course, they reaching Earth more or less the same time. Why? While they are falling, the air is resisting in the opposite direction. Air is acting in the opposite direction. In this case, the mass is even 1 kg, volume is less because the small area is exposed to air. Some resistance, air is resisting some force in opposite direction. Whereas in this case, 0.5 kg mass, but large area is exposed by the air. So more force is acting in the opposite direction by the air. Suppose we assumed there is no air, the both are falling, reaching the ground more or less in the same time. This is the proposed observations are proposed by the Galileo. Of course, after Galileo that was proved by this Robert Boyle. Robert Boyle, he took some tube and he put in one coin and one feather, feather. In this tube, air is removed, so created vacuum, and these two are allowed falling through this tube. Almost both are reached together same time. So that is proved. So that's why while we are calculating acceleration due to gravity, we are not taken the taken the air resistance upward direction, not taken into the consideration. Now we can calculate acceleration due to gravity. Acceleration due to gravity, g denoted by small g. So we know that the F equal to force equal to constant of gravitation into mass of earth into object divided by r square, where we know that m is mass of the earth, m mass of the object, r is radius of the earth. So from this Newton's second law, acceleration equal to force by mass of the object. This is equal to, in force you can substitute this term g into me, m small m divided by r square divided by m. So therefore they get cancelled, get cancelled, so that this equation becomes g into me divided by r square. So therefore finally acceleration due to gravity g equal to m into g into capital G into me divided by r square. We have all these values, g value we know, me value we know, r of the earth we know. So if you substitute these values, 6.67 into 10 to the power minus 11 Newton meter square per kg, meter square per kg square into this is the g value, this is the radius 6.4 into 10 to the power 6 meter square r square, whereas this is the mass of the earth 6 into 10 to the power of 24 kg. So if you simplify this one, finally you can get 9.8 meter per second square. So one more thing we have to understand here. Of course, that means 9.8 meter per second square means while it is falling, every 1 second, the object is accelerating meter per second. Second velocity, 9.8 meter per second velocity is accelerating. So accelerating. In one more thing you have to understand here, proposed by these people, while it is falling in this direction object, it is going in this direction, or it is inclined, the g value does not change, that is equal to 9.82 meter per second square. Thank you.